Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science, Jesus and Mary College, University of Delhi. So we are taking up different topics in computer science and discussing those topics in detail in series of lectures. And if you would recall, in the last few lectures we were talking about operating systems and we had discussed various aspects related to the basics of operating systems. So even in this today's lecture also we are going to talk about the main fundamentals of operating system. Basically this is an introductory lecture to operating systems, and as we go on in this series of lectures we will be talking about each of the topics in more detail. So if we talk about this particular lecture, so today's lecture will be of use to undergraduate students as well as postgraduate students who are doing an introductory course in operating system, and a lot of today's lecture will be generalized foundation laying kind of lecture, and then we will progress. As we progress we will delve deep into the different topics that we will be covering. So just a very quick recap of what we had discussed in the last lecture about operating system. So we had said that basically an operating system is an intermediary which acts between the user of a computer and the computer hardware. So operating systems basically they have multiple goals, and the foremost goal of an operating system is to make the use of a computer system easy and convenient for the user, so that the user can execute the programs and solve the problems and fulfill the objectives of using the machine in a very user friendly manner. So it makes the entire system very convenient to use, and it also enables us to make the use of computer hardware in an efficient manner. So different operating systems they are used for different purposes, and the purpose of an operating system, or the main goal or the main objective of an operating system will vary from device to device. For instance, if it is a mobile system for which you are looking at an operating system, so you will look at features such as better battery life or low power consuming operating system, or that kind of a system which is smaller in size and different like that. If you are looking at an operating system for a mainframe system, so there the efficient use of hardware will be your prime objective. So depending upon what system is going to deploy the operating system software, we will have different priorities of using or choosing a particular operating system. So we had thought that some operating systems they are designed to make it more convenient, other operating systems are defined or designed or used, or the objective is to make it more efficient, and there are some others which have twin objectives, that is making it convenient as well as efficient to use. So basically we had discussed a lot about how operating systems function and what are the different types of operating systems. So if we look at multiprocessor system, so we had looked at something called the batch processing system. Now we look at the multiprocessor system. So basically the name itself suggests that multiprocessor means that these systems are going to have more than one processor, more than one CPU. So these systems, the multiprocessor systems, they can be of two types, or they can generally we classify them as symmetric multiprocessor systems and asymmetric multiprocessor systems. Now what is symmetric and what is asymmetric? Let us look more deeper into it. So if you talk about asymmetric multiprocessing, so we understand that multiprocessing means that there will be more than one processor, but in asymmetric each processor is assigned a specific task. So there is a boss processor, you can say, which controls the entire system, and the other processors will look towards the boss processor for instructions or have predefined tasks. So this scheme defines a boss worker relationship. Okay, so a superior subordinate relationship. So there is one processor which is going to schedule the work, which is going to allocate the work to all other processors. That is why this is known as asymmetric, because there is a hierarchy amongst the processor. One processor is acting as a controller to the other processors, whereas in a symmetric multiprocessing, each processor will perform all the tasks within the operating system. So symmetric multiprocessing will mean that all processors are peers, that is, they are all equal, and there is no boss worker relationship which exists between them. So all tasks can be given to all the processors. There is not one single processor which is going to control the distribution of jobs between them. So in this case, symmetric multiprocessing, we will see that if you have, say, 3 CPUs, so CPU 0, 1 and 2, so they will definitely, they are having a shared memory, but they are all alike. So CPU, every CPU has its register, every CPU has its cache, and they are all connected to the common memory. Then there is another very important type of system which is known as the clustered system. Now clustered systems are, they are different from multiprocessor systems, because in that they are composed of 2 or more individual systems or nodes which are joined together. So such systems, they are considered as loosely coupled, because each node may be single processor system or a multi-core system. So basically this is, cluster means that it is a group of systems which are working together. So in this you can have 2 nodes, you can have 3 nodes, you can have n number of nodes, and these nodes, they are connected. They can have one processor, or they can have multiple processors. So like multiprocessor systems, but they are different because multiple systems are working together in a clustered system. So usually there is, sharing storage via storage network. You provide high availability service which survives failure, and there can be asymmetric clustering where one machine is as a hot standby machine, or there can be symmetric clustering where you have multiple nodes running applications monitoring each other. So different types of clustering can also happen. Just like you have symmetric and asymmetric multiprocessor systems, we can have symmetric and asymmetric clustered systems also. So some clusters, they are for high performance computing, that is very important, HPC. So then for this happens using parallelization. So separate application programs are to be written for running the certain portions parallelly amongst different systems. So there can be horizontal division of work, or there can be vertical division of work, and then some have distributed lock manager to avoid conflicting operations. So when you are using a clustered system, when you are working on a system which is sharing work, then definitely there has to be a mechanism to avoid conflict. So for that there is a DLM mechanism which is known as the distributed lock manager system. So this is what a clustered system looks like. So you have got 3 computers which are actually interconnected with each other, and they are also connected to a storage area network in a clustered system. So operating system structure, if we look at what is the structure of the operating system. So one of the most important aspects of operating system is the ability to multi-program. Now multi-program means that at the same time multiple programs can be executed on the computer system. It is very important that when we start this journey, we understand very clearly the difference between multi-programming system, multi-processing system, time sharing system, real-time system. So these are different categories of processing systems which occur. So we've talked about multiprocessor systems in which more than one CPU can exist. Now what we are talking about is a multi-programming system. So a single program cannot in general keep either the CPU or the IO devices busy at all times. So single users they frequently run multiple multiple programs, and multi-programming or running more than one program will increase the CPU utilization by organizing jobs so that the CPU always has one job to execute. Because we understand that the CPU and the IO devices, they are very critical resources of a system, particularly the CPU. So therefore, the main objective in a computer system should be to not let the CPU remain idle. So if you have a single program running, and if that program goes for some kind of input output from the console, from the user, then definitely the CPU is remaining idle. So this is not a desirable situation, and the most optimum use of CPU is possible by introducing the concept of multi-programming, so that the CPU utilization is optimized, and the work can be organized so that the CPU always has something to execute, some program to execute. And who does this organizing the work for the CPU? Of course, this is the job of the operating system. So the operating system will keep several jobs in the memory simultaneously, and since in general main memory is too small to accommodate all the jobs are kept initially on the disk in the job pool, and this pool consists of all processes residing on the disk awaiting allocation of main memory. So what happens is that the CPU will read the data only from the main memory. Now the main memory is a small memory which cannot hold too much of data. So the data which is ready to be executed or which needs to be executed, it is kept on the disk on an area which is known as the job pool, and in this job pool the processes are going to be kept which are awaiting allocation of main memory. So from the job pool the process will be transferred to the main memory, and from the main memory these will be transferred to the CPU for allocation. So the set of jobs in the memory can be a subset of the jobs kept in the job pool, because they are being picked up from the job pool. And who is doing this work of picking up jobs from the job pool and putting them in the main memory? Of course, it's the operating system which picks and begins to execute one of the jobs in the memory. So eventually the job may have to wait for some task such as an IO operation to complete. So in a non-multi program system, the CPU would sit idle. When the process is going for IO, the CPU would be idle. But in a multi-program system, the CPU will switch to another job and it will start executing another job. So it is like, it is like a sequence of jobs. If one job goes for the IO, the next job will take up its position. The next job will be assigned to the CPU so that the CPU does not remain idle at any time. So when that job needs to wait, the CPU switches to another job. So this keeps on continuing. Eventually when the first job finishes waiting and gets the CPU back, so as long as at least one job needs to be executed, the CPU is never idle. So this is the philosophy of how multi-programming systems are designed. That is the core idea being the CPU to remain busy, to remain executing tasks at all the time. So this is the memory layout for a multi-programmed system. So we can see that there is an operating system and this is job 1, job 2, job 3 and job 4. So this is actually the job pool, and the operating system will pick up the job and it will assign it to the memory, and from the memory it will be assigned to the operating system. So likewise, this shifting or shuffling of jobs will keep on happening till the time there is at least one job for the CPU to be executed. Now, what is the structure of the operating system? This is rather important. So we are talking about time sharing or multitasking operating system. So this time sharing or multitasking is a specific type of multi-programming system, because in time sharing requests are the CPU execute multiple jobs by switching among them. but the switches occur so frequently that the users can interact with each program while it is running. So actually the user will not know, or the process will not know, that any other program is sharing the CPU. The switch will happen so frequently. So every program will understand that the CPU or the entire control of the processor is with that program only. However, multiple programs are being run. So there is a time slicing which happens, and every process gets a slice of the CPU time. And once that time slice is over, the CPU shifts to the next process. But the users which are interacting, they will keep on working as if the CPU has been assigned to them. So time sharing, basically it will require an interactive computer system which provides direct communication between the user and the system. So the user gives the instructions to the operating system or to a program directly using an input device such as keyboard or mouse or different input devices, touch screen, touchpad, etc. And it will wait for immediate results on an output device. So accordingly, the response time should be short, typically less than 1 second. So that is what time sharing systems are more critical systems. So time shared operating system therefore will allow many users to share the computer simultaneously. Since each action or command in a time shared system tends to be short, only a little CPU time is needed for each user. And as the system switches rapidly from one user to the next, each user is given the impression that the entire computer system is dedicated to his use, even though it is being shared among multiple users, as I just said. So this is one very important attribute, that every user will get a very small slice of the CPU's time, because the process is such that only a small amount of time is required for the execution. Then the next process comes in place. So time shared operating system, they use CPU scheduling and multi-programming to provide each user with a small portion of a time shared computer. Each user has at least one separate program in memory. A program is loaded into memory and executing is called a process. So this is very important. Now we are going to talk about how the process management is done by the CPU, because what we are looking at is, we are looking at a CPU in which multiple processes are being executed or multiple programs are being executed. So in later stages of this discussion, we will understand that what are the different CPU scheduling algorithms which are used in a multi-programming environment, so that equal amount of CPU time is given to each of the running process. So but we have been using this term process very often, but it's also very important to understand what is the difference between a process and a program. So when a process executes, it typically executes only for a short time before it either finishes or needs to perform I/O. Now I/O may be interactive, that is, output goes to a display for the user and input comes from a user keyboard or mouse or any other devices. So whenever a process is executing, it is going to take turns. It works in turns. It goes to the I/O, then it comes back to the CPU, then again it goes for the I/O, because continuous interaction with the user is going to take place in case of a time sharing environment. So since interactive I/O typically runs at people's speed, so it may take a long time to complete. So input, for example, it may be bounded by the user's typing speed. If a person is typing really slowly, so then that much amount of time will be lapsed, will be extra in the I/O, right? So rather than letting the CPU sit idle as this interactive input is taking place, as the user is typing at his or her own sweet pace, then the operating system will rapidly switch the CPU to the program of some other user, because the the time which is elapsing in IO has to be given to some other user. The CPU cannot be left free like that. So time sharing and multi-programming, they require that several jobs are kept simultaneously in the memory, because several jobs are to be ready to be brought into the memory, and if there is not enough room for all of them, then the system must choose among them, right. So therefore the system continuously, the system has to keep swapping the processes to and from the memory, so that there is a regular supply of processes for the CPU. So making this decision involves job scheduling. That is how a particular job is, till what time a job is to be kept in the memory, and after how much duration the job is to be kept out or is to be removed from the memory. So when the operating system selects a job from a job pool, it will load that job into the memory for execution. Having several programs in memory at the same time will require some form of memory management also. So in addition, if several jobs are ready to run at the same time, then the system has to choose which job will run. So making this decision as CPU scheduling. So what we are talking about here is, we are talking about multiple types of algorithms which will come into play while the jobs are being scheduled. That is how the jobs are to be arranged in a job pool, and when a number of jobs are ready to be executed, then how the CPU will choose which job is to be executed first. So there can be, for instance, there are different algorithms, like one very common algorithm is last in first out. The job which is the last to come in is first to go out. Or there is another algorithm, first in first out, that is the job which is first to come in will be the first to be assigned CPU. Or there can be another algorithm which is the lowest amount of time. So the job which is demanding for the least amount of CPU time gets the first chance. Now there are pros and cons which are involved in all these scheduling algorithms, but multiple factors come into play on how the CPU scheduling and job scheduling will be done. So finally, when you are running multiple jobs concurrently, it will also require that the ability to affect one another be limited in all phases of operating system. So including process scheduling, disk storage, and memory management, because two processes which are running concurrently, they cannot affect each other, otherwise there will be more problems related to concurrency control or deadlocks, which are also very, very significant. So we will be continuing our discussion on operating systems. Till then, thank you.